Our goal today is to try to get through a good chunk of factoring and refresh your memories. For those of you that were here this summer and took that time, it's going to really pay off today and tomorrow. Okay, and quite honestly, throughout the rest of the year. Now, just so that we recall, the point of factoring for us right now for this chapter is going to be to solve quadratic equations. But it also helps us to graph quadratics. It'll also help you to simplify equations later on in the year and simplify expressions. So there will be some times when you're tempted to do shortcuts, and I'll say, hey, you really should make sure you understand what you're doing here, because it's going to catch up to you in Chapter 8 and Chapter 9 when you start looking at factoring and you no longer see x's, you see sine and cosine and tangent. Okay? That's stuff you can't just plug into your calculator, which some of you are going to be tempted to do here in a while. All right? So, steps for solving quadratics. Now, before you start cranking out all these notes, right, all this stuff is on here. Yeah, I put it on there so you don't have to write it all down. Okay? That's why you have the other side of that sheet. So the steps for solving quadratics, in fact, if you're looking at your sheet there, first thing you always want to do is write it in standard form. Okay? Now there will be other processes you may try to use, but if you're solving them algebraically, it's helpful to have it in standard form. Always look for a common monomial factor. In other words, a greatest common factor. For instance, I gave you an example there. If I have the expression 8x squared plus 16x plus 6, and I say, well, what can I take out of these three terms? Well, I could take a 2 out of each. So when I pull a 2 out, 2 times 4x squared is 8x squared. 2 times 8x is 16x. And 2 times 3 is 6. Okay? So I try to pull out a greatest common factor. All right. Now from there, what I'm left with inside here, you have this quadratic left in there. Okay, so if you're taking a look at that, and we were to kind of continue through there, that quadratic that's in there, we look at, and we then try to factor that. The 2 on the outside's there, but it's not going to have any effect any longer on our solution for what x is. Okay, so if I'm trying to factor that quadratic, Lizzie's method, the method we're going to go through in class, and I realize some of you have done Lizzie's method, some of you have done box methods, some of you have some use this thing called the string method. There are a lot of different ways teachers teach it. I will limit myself pretty much to Lizzie's method. Okay? So if there's another method that you remember and you are very good at, you're more than welcome to use it. All right? If you're using Lizzie's method, just the quick overview. Pay attention, please. You multiply A by C. Okay? A meaning this, that's A. B meaning that, C meaning that. A times C. Okay, or 4 times 3 in this case. Once you multiply 4 by 3,
4 by 8.
or 4 by 3,
Oh, sorry, 4 by 3.
so we get 12 x squared. Okay? We then find all the factors of AC. And is it positive or negative? Well, 4 by positive 3 is positive. And then the factors of 12 are 1 by 12. And I'm going to ignore the x for a minute. I know it would be 1x by 12x. Okay? 2 by 6. And 3 by 4. Now you'll notice when I did that, I actually listed them in an order that it's easy to see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've tested all numbers between 1 and 12 because I've been orderly about it. Okay, if you are a random abstract person that doesn't list things in order, this will be tougher because sometimes there's going to be a lot of factors. Okay? Then you need to think, well, what combo has a sum of B? Well, what combo adds up to 8? 2 and 6. Okay? Divide that combo by A and then reduce. So if I take that 2 and that 6, let me zoom out there a bit. If I take that 2 and 6 and I divide them by A, So my A term is 4. So I'm dividing each of them by 4. Be nice if that would focus. Okay. Divide that by 4 and divide that by 4 and reduce. 2/4 reduces to 1/2. 6/4 reduces to 3/2. Okay, I'm now left with that and that. Set them up in quantities. Now I actually, when I do this with you as a class, I do this sometimes a bit differently. I like having my quantities set ahead of time, just because I can look right here and say that's positive and that's positive. That tells me that these are both plus. How do I know that? Well, I've kind of given you a guide here. C is negative, then it's minus plus. C is positive, then it's plus plus. If C is positive and B is negative, then it's minus minus. So if C is positive, you got to look to B, and that tells you what your quantities are. In this case, C is positive and B is positive, so it's plus plus.
What if both B and C are negative?
C is negative.
Yeah.
We don't care about what, it's automatically negative plus. Okay? We don't care about, if C is negative, we don't care about what B is.
Okay.
Okay? It's only when C is positive. And that's because when you multiply your back term, when you're foiling this, positive times positive gives you positive, and negative times negative also gives you a positive. Versus here, you get negative times positive or positive times negative. They both give you negatives. Okay. So once we have that, we set up our quantities. Are our symbols accurate? And we solve for x. Well, in this case, what I'm doing is I'm putting the denominator out here, 2x, and 2x. And my numerator goes right there and there. I've now factored that. This is the factored form of this quadratic. Now, note the 2 here. This 2 would actually be hanging out here if we were to continue it. And the whole point of doing that is because now what I can do is I can say, well, I know that 2 times quantity 2x plus 1 times 2x plus 3 equals 0, which means if I'm multiplying 3 things, that 2 by this quantity, by this quantity, okay, so I'm multiplying those 3 things to get 0. In order to get 0, one of those 3 things has to be 0. And I know for a fact,
Sorry.
you all right?
Yeah.
I know for a fact 2 isn't 0, right? Okay, but I do know that if this was 0, you guys are pretty good at this. You've been doing it a lot this year. Okay, we subtract 1, divide by 2, x would be negative 1/2. And if this part was 0, I would subtract 3 and divide by 2, x would be negative 3/2. Those are my solutions right there. That's the whole purpose of what we're doing, is to solve for x. Now, we're not going to jump right into solving for x. We're going to start by factoring. Okay, and that's kind of where we're at today. All right? We're going to start with the factoring, which once we factor, then we'll get it down to solve for x. So that's kind of the general overview of what we're doing here. Just so you understand, in your graph, this negative 1/2 means my graph crosses. That's an x-intercept. That's when y is 0. Okay? That means it crosses at negative 1/2, and it crosses at negative 3/2. And this parabola I know opens up because a is positive, so it does something like that. Okay? And it goes through 3 on the y-axis up here somewhere. So we'll just say right there. Now that's a really rough sketch of that parabola, really ugly looking. But, I'm just trying to point out what's happening there. Okay? I know, really bad, but that's okay. All right, now I'm 1 minute off my goal here. That wasn't my plan. 2 minutes off my goal. It's ridiculous. Okay, so we're going to start in on our assignment right now. So what I want you to do is take a look at the sheet that you got on the way in, the actual assignment sheet. I know you got like 30 million sheets, but the one that I want to work on is problem 32. Okay? Besides the no, this is mixed side. besides the problems we're doing as a class today, okay, your assignment is going to be mixed side number 32, number 35, number 62, and then example side 1 through 20 and number 43. Today. Don't cross anything else out. All right, so let me say it again. In fact, I'll write it right here. Mixed side today, number 32, number 35, and number 62. Example side, 1 through 20, number 43, and actually I'm going to let you skip number 16 in that 1 through 20 set.
16 and 7?
No, just 16. I want you to do 17. Man, gee. Going back for seconds already. It's not even Thanksgiving. Gee. All right. Okay, which means we're starting as a class. We're going to do 4 of these together. We're going to do these 4 as a class. Huh? Those 4. What's that? Okay. All right, here we go. Let's dive into it, man. Solve each by factoring. Now, the first, I gave you this list and I said write in standard form and blah, blah, blah. I guess the one thing I didn't add here, and maybe you should put, you don't have to factor unless there's an A term and a B term, okay, and a C term. If there's no B, you don't have to factor. Okay, all right, if there's an A, B, and C, then you factor. Well, or I guess you don't even. If there's an A and a C, you don't need a factor. If there's an A and a B, you should factor. I guess maybe a better way to say it, if there's a B term, you must factor. Or use the quadratic formula, or use difference or perfect, or completing the square, excuse me. If B is not there, that is an easy problem to solve. B, the problem. B makes it tougher to graph them. B makes it tougher to solve them. B is the problem. So when people walk around and go, yo, what's up, B? B is the problem. That B, be the problem. Okay? They're like a problem. I'm serious. All right, so first step. Okay? What do we need to do? Yep. Subtract 6. Get it in standard form. So we get 2x squared minus x minus 6 equals 0. Okay, now I'm just assuming you guys are doing this on your note page. Some of you will want to do it on a piece of paper, I guess, but I would do it on my notes. Okay? All right, is there a B term?
Yes.
Yes, so that's the problem. All right, so now we move into the second step. Okay, we try to take out a greatest common factor. Can we? No. Now we move into the third step. Multiply. Now I'm following these steps here, right? So we're into Lizzie's method all of a sudden. 3, multiply A by C. So there's A, there's B. Now B, that's a 1, right? And there's C. So A times C is? Negative 12. I'm going to ignore the x squareds in there, okay? Okay, negative 12. 2 things that multiply to make negative 12 and add to negative 1 is what we're looking for. So now I won't always list all my factors. I'll list as many as I need to. Right? So 1 times 12. Well, we'll get to that, yeah. So it has to make negative 12. So does 1 times 12, one of these has to be negative. So if I say negative 1 times positive 12, will that add to negative 1? No. How about 12 times, or negative 12 times positive 1? No, really I'm looking for 2 numbers that are factors of 12 that are differ by 1 right now. 2 doesn't, 2 and 6 doesn't, but 3 and 4 does. Right? Because which one's negative? The 4 is. I need to have more negatives than positives. Okay? Now, I'm going to set up my quantities right here. This is a bit out of the order, but if I set up my quantities, I always know my x's go there. What are my symbols? Go ahead and tell your neighbor, what signs do you put in here? Okay? What are they? Yeah? Plus minus. Why is it plus minus? Someone give me a good reason. Someone besides Hannah gave me that answer. Rafi?
Because it's a negative.
Because what's a negative?
Because the B term is negative.
No. C term's negative, yeah. We focus on the C, right? Plus minus. C's negative, so it makes that plus minus. Now I'm going to go ahead and put my 3 and 4 in there. I'm going to just go ahead and insert positive 3 and negative 4. Now, what have I not done?
Divide by A.
I didn't divide by A, which will be the common mistake. So a lot of times I put those in and then divide by A. What is A? 2. So sometimes, a lot of times I show it like that, which gives me x plus 3. Well, I can't reduce that, so that 2 moves out to there. So 2x plus 3. Okay, and x minus, well, can I reduce that? 2. You should be able to do a quick check. My quick check is I multiply the fronts. 2x squared, that's what I have. Multiply the backs. Negative 6, that's what I have. Okay, and then if you want, you could say, well, that's 3x and that's 4x, or negative 4x, so that's negative x. Okay, I have now factored it. Have I solved it? No. Solving. Set that equal to 0. 2x plus 3 equals 0. What 2 steps do you do to solve? Tell your neighbor. Okay, we subtract 3 and divide by 2. It's negative 3 halves. And x minus 2 equals 0. X equals 2. Now those of you who are like, I don't get what he's doing there. Well, you're subtracting 3. Okay, so you get 2x equals negative 3. And then you divide that by that 2. Okay? And those are our solutions. Usually we write it in set notation. Negative 3 halves, 2.
Isn't that that's basically when we divided the negative 4 and the 3 by A, that's basically what we got with the sign.
Yeah.
Is that just a coincidence or not?
Hey, so Lee pointed out here, and this is where I get the students that like to do shortcuts, and they're like, well, I'll deal with the other stuff later. Like when I get to chapter 8 and I don't know how to factor, I'll deal with that then, man. Okay, well, that's your call. But Leah saw the good pattern here. She's like, well, isn't that just that and that? Aren't those your answers? Oh, yeah, they are. I mean, right? If I set this equal to 0, that's negative 3 halves. And if I set that equal to 0, it's 2. Well, why don't we just stop there? Because you're practicing factoring. If you don't practice it now, I will guarantee you, chapter 8, chapter 9 come around, you will struggle mightily. And then you'll go, well, I don't know how to factor. And I'll go, well, you better go back and watch all those videos for chapter 5. And good luck, dude, because it's going to be a tough go for the end of the year for you. Okay? Please heed the warning, factor. But I will tell you, this is a good check, for sure. Yeah, good point, Lee. Christy.
So when there's no C value, like we do.
We'll get to that. When there's no C value, what do? We'll get there.
Isn't that just 0?
Yeah. It's which one?
It's on number 4.
Number 4. Are you working through these with us?
No, I was just looking through them.
Oh, I see. Yeah.
For the second parentheses one, you know how you took the 2 on the first one and put it in front of the x?
Yeah.
What did you do with the second one? Like on the second parentheses, what happened to the 2 underneath the 4? Oh, you just went to
I reduced it.
Reduced.
Yep.
Gotcha.
All right. Hey, 35. Everyone try 35, please. Okay, standard form, can't reduce. So a by c is 10. 1 times 10, trying to add to 7, so 2 and 5. Both plus in it. Divide by your a term. Don't forget to divide by a. If you keep forgetting that, make sure that you make yourself a note. Reduce. Okay, any questions to there? How many made it there? Good. Okay. X equals -1. Two things right here. -2/5. Okay, so usually write it in set notation. -1, -2/5. Any questions, Lily?
Does it matter which order you put it in?
Doesn't. Usually I go numeric, but yeah.
I'm confused on how you go from the x plus 2/5 to 5x plus 2.
You move that out in front.
That's it?
That's it. Yeah. Other questions? And this one I reduced, right? All right. Now you think you got it. Okay, you can skip 62 and 43 then. Good job. All right. You can skip those. 62 and 43 you guys are good on. Okay? Want you to take a look at the one that Miss Aldridge asked about. Okay, so Christy, what was your question again? What do you do if there's no c value? For instance, number 4. Well, I started out the same way. I go x squared equals 6x. This is a special case. And from there, I try to write it as in standard form, so x squared minus 6x equals 0. Okay, what's the first thing in factoring you're supposed to do after you get to standard form? It's the thing that most of you will forget. Some of you have already forgotten it. You'll forget to do it, and it's going to catch you on a quiz test. Look at your notes. You have them.
Oh,
Come on, man. Oh, everyone's waiting for someone else to do it. We should read. Whose job is it? It's such a good quote up there, and Spogel has it on his. Whose job is it? Maybe we should. We don't have time to read it right now. Right now, it's your job. Okay? What is the second thing you do? I don't even have my note page anymore. I tossed it over there. Yes, Owen?
You do a times c?
No. Yes? Look for a greatest common factor. Standard form, and then look for a greatest common factor. Okay? What is the greatest common factor? X. You can take an x out of both those. X times what is x squared? It's x. X times what's negative 6x? Negative 6. You have now factored it. That's why it be so easy without b.
wow, that's awesome. Oh,
This?
That's without C.
So what's the restriction?
That's without c. I'm sorry. Without c. Okay? Right here, this becomes? What makes this 0?
Oh, 0.
0. What makes this 0?
6.
Those are my solutions. I'm serious. I wouldn't joke.
It's pretty cool.
It's really cool, actually. Just without the rows and columns. Okay? Other questions?
So, what exactly do you do when there's not a b term, like on number 12?
Like on number 12. Wow.
Oh, wait,
well-
no, there's a b term on number
Oh,
12.
darn.
There was one. Yeah, here, we get number 14.
Like number 14. Well, I'm glad that someone brought it up. How about we try number 14?
How about Peyton?
How about number 17?
Number 3 has a b term, too.
Okay, there we go. It's in standard form. Can I take out a greatest common factor? No, but there's no b term, so really, I could just solve for x.
Oh, okay.
right? 9x squared equals 1. Add 1 to both sides.
Divided by 9, square root.
Divide each side by 9, so we get 1/9 equals x squared.
Square root.
Take the square root.
That's equal to x. Positive,
Thank you.
negative.
Plus minus.
Plus minus 1/9. Now you can't leave it like that. You can't have a. Now I let you, when we're finding inverses, I don't make you rationalize the root, which means getting the fraction out of the root. But when we're solving, we have to. So that means you have plus minus root 1 over root 9, which is the same thing as plus minus 1/3. Don't forget the 1/3. Thank
You're
you.
on. Yeah.
Oh, okay.
Okay.
Wait, what?
Oh, okay.
Yeah, because root 1 is 1.
Oh.
So, you guys, if there's only 2 terms, it's a lot easier, right? If you're missing B, it's really easy. If you're missing C, it's pretty easy. You still have to factor. But if there's only 2 terms, it's a lot easier than when there's 3 terms. Okay. All right, so we've hit even the special cases, which is tomorrow's lesson.
Oh, so we're already done
Well,
with
most of
tomorrow.
it. No, we're done with part of tomorrow's.